I'm Saravana from Qualcomm. I'm the DVFS team lead. I'm here to talk about WALT versus PELT. The agenda would be like a really short intro on WALT, a really short intro on PELT. If you attended Vincent's talk, you wouldn't need that intro. And why we have these two things. Where do we stand today, and are we there yet in terms of PELT being on par with WALT or better, and what are the next steps? So to give a quick introduction of WALT stands for Window Assisted Load Tracking. It's a quick authored solution. When I say quick, it means Qualcomm Innovation Center. That's who I work for. WALT basically tracks a thread's load as runtime within a 20 millisecond window, and the windows are globally aligned. And this was work initially started by Steve Muckle here. And so the windows are globally aligned across CPUs, and we measure the load as runtime within the 20 millisecond windows. So it kind of gives a short-term historic view of the thread. PELT stands for Per Entity Load Tracking. It's an upstream solution, and it tracks a thread's load as a runtime geometric average. And it splits up the time into about 1 millisecond segments, and each segment contributes some amount to the geometric average. There are three variants of PELT, PELT 32, 16, and 8. They indicate a load's half-life time. So if a load is at a value X and it goes idle, in 32 milliseconds, the value will be half of what it was before. So that's the half-life here. So you can think of PELT 16 as reacting much faster to threads running or going idle compared to 32. And PELT 8 is an even faster version. So why do we have WALT and why do we have PELT? So for WALT, we have WALT from Qualcomm. We have authored it because it's better for interactive loads. It works well for interactive loads. It's optimized for mobile devices, and it's also meets some of the commercial device requirements we have. Why PELT? PELT is an upstream solution, so if you use it, it's a lower maintenance cost. And it also gives a unified tuning interface for user space like Android. If every phone uses PELT, then you have a unified tuning interface. So is WALT all about Windows? No, it's not. Load tracking is just half the picture. How you actually use the load is also equally important. And Quick has actually done several value adds on top of WALT. And when somebody talks about WALT, they're really referring to WALT with the value adds. Nobody just means just the load tracking component of it when they say WALT. So where do we stand today in terms of the comparison of PELT versus WALT? Quick wanted to know the answer to that too. So Quick has been evaluating PELT, and to do that, the DVFS team and the Scalar team, we have been porting all of our value adds on top of PELT. And we have been doing a lot of profiling on it. That way we can do some comparisons between those two. This is work in progress. I'm here to just present some early data to kind of give an idea of where things are going. So take it for what it is. And before I present the data, some baseline assumptions and terminology. All of this work has been done on an 414 kernel. And whenever I say PELT on the subsequent slides, I always mean PELT with the util-estimate patches, with the RT level run queue tracking PELT signal backported. And we've also explicitly removed the upstream change to jump to max frequency whenever an RT thread is running. Jumping to max frequency for an RT thread just doesn't cut it for a mobile device, because Android uses it, I think, almost every frame render. If you use a surface flinger, it uses an RT thread. So jumping to max frequency just doesn't cut it. And also, when I say value add 1 and 2, basically I'm grouping all the Qualcomm value adds into different sets and calling them value add 1, value add 2. When I say value add 2, it's a cumulative value add, so it'll have all the changes from value add 1. And whenever I say WALT in the rest of the slides, I'm only talking about WALT with the value adds that have been ported over to PELT. So we have turned off value adds that have not been ported over to PELT yet. So this kind of gives you an apples to apples comparison. So let's take a look at Geekbench. So if you look at Geekbench and do a WALT versus PELT 16 comparison, the scores are all pretty much on par. So on the graphs, I'm plotting WALT as 100% bar, and everything is normalized to the WALT scores, or WALT power numbers, whatever I'm presenting. So if you look at it, Geekbench is already on par, and you see some cases it looks like it's better, PELT 16 is better, but that seems to be mostly run-to-run variation in Geekbench. What this really says is that Geekbench is more like a measure of your car's top speed than how fast you can get to, say, 100 miles per hour or 100 kilometers per hour, sorry. So from the perspective of Geekbench, I think we're pretty much done. There's nothing more to do for Geekbench in terms of changing PELT. But moving on to ANTU2, you'll start seeing that there are some regressions in some subtests that are like non-trivial. Memory subtest, for example, that's about like 10% regression there. And one thing we do at Qualcomm is that we don't really look at the total score of a benchmark because it kind of has some arbitrary weightage of the subtest. And sometimes you're adding subtest scores which don't have any sense of a unit. So if one of the subtests has a really high score, it kind of mask out every other subtest. So we look at it at a subtest level to get a better idea of how each subsystem is performing. So yeah, that's the status for ANTU2. Moving on to PCMark, that's where you start seeing substantial regression with PELT 16. And PCMark, two subtests have like about 20% regression, the web and writing. The other subtests kind of are on par with WALT. And if you go look at power, the power for PELT 16 is better. So this is not like surprising. You know, you get for lower performance, you can get away with lower power. Seems reasonable. But we still want to achieve the performance of WALT on PCMark. So going over to real world use case, that's when things kind of get murky. In some cases, PELT has more power consumption than WALT. In some cases, PELT has lower power consumption. So in all the power graphs, lower is better. Yeah, when I say power here, I'm just talking about the power of the CPU, the chip infrastructure, and the memory. So these are all the parts that can be affected by changing between WALT versus PELT. So for example, I'm not including the display power or the Wi-Fi power because they're mostly irrelevant in terms of comparing WALT versus PELT. And if you have a really bright display, it can wipe out any savings you might get on the CPU. So it doesn't mean it's not important. So the use case are compared to YouTube, 3 different games, and a browser use case. And YouTube is clearly about 9%, I think, or 7% worse than WALT. So we ported over value at set 1 to see where it brings us. And I'm going to skip talking about Geekbench from here on out because there's like nothing to talk about there. So comparing WALT versus PELT 16 and value at set 1, we see that it recovers most of the regression in ANTU2. There still seems to be some regression compared to WALT on the memory subtest, but the rest of the subtests have caught up with WALT. Moving on to PCMark, you see actually substantial improvements in all the subtests. But you see that some subtests are still worse than WALT. Even though value at set 1 is improving, we haven't caught up with WALT yet. So mainly the web and writing are worse than WALT, clearly. Moving on to power, this is where it kind of gets interesting. With value at set 1, the power actually reduces compared to PELT 16. So you get better performance and better power. And if you go look at performance per milliwatt, you see the efficiency actually improves because you get more performance with lower power. This is really the kind of direction you want to go for most of the changes you do. Except the only time where you wouldn't want to do something like this is you might be able to get a higher efficiency point with more performance, but the performance is not really useful. If it doesn't actually end up showing any changes to the end user, you might not want to do that at times. That's generally not the case. So if your display is frame rate limited to 60 frames per second, reducing the frame time from 8 to 5 it's a higher performance, but like no practical impact. So in those cases, you might choose to run at a lower efficiency point, because the overall power you use is still lower compared to a higher efficiency point. But going back to this particular use case, this seems like a good change. But then if you go to real world use cases, again, there's no consistent picture here. Power reduces for YouTube. It increases for the light game too. And for browser, it increases a tiny bit. But at least for browser, the tiny bit increase in power comes with a huge improvement in performance. If you go look at the web subtest, that's about, I think, 7% improvement in performance. You get that for like a 1% increase in power or so. Yeah, so everything's improving, but it's still not hasn't caught up to WALT in terms of power in all the use cases. So we went on and added value add 2 to see where it takes us. So again, this includes the previous changes from value add 1. Oh, by the way, feel free to interrupt me at any time, actually. We have plenty of time. I don't have as much slides. So sorry. Yeah.
Can you remind the value added 1?
Sorry, what do you mean remind?
What is included in the
we intentionally
first?
kind of kept it abstract because we didn't want to get into the details of the changes yet. This is just a group of changes we've done for the scalar and DVFS algorithms. And I'm not getting into the details of them here.
Okay.
Sorry.
So yeah, just clarifying on that, the case where there's no value add, does that mean that this is what we would observe if we did this experiment, say, on Android common kernels? Or is it?
Yeah.
Is there still value adds in there that may affect this?
There are no significant value adds that would affect this. So we have tried to make it as close as possible to Android mainline.
Okay.
But we've also, if we go back a few slides, I talked about what we backported and what we disabled. So we do those things, we do expect you to see this behavior.
So without VA1, there's no value adds on WALT?
No, WALT is always the same, right? Because I want to keep that constant. So yeah. I have, like, say, 2 value adds that I'm porting over to PELT, right? I want to compare to where is WALT with those value adds, okay. Right? I'm kind of showing how much it helps you catch up with WALT or not catch up with WALT by adding these value adds. So WALT is constant with value adds at 1 and 2. But a bunch of other values that we have disabled explicitly that would be on the shipping kernel for Qualcomm devices. And I'm comparing it to that. Actually, any more questions?
So you say that you can't give detail for value added 1 and 2. Will you release anything at some time or upstream that?
This is too early to kind of see because we're actually changing the value add, what value add 1 and 2, okay. Tweaking the implementation because they're all changes on WALT. Okay. Kind of trying to massage them to work on PELT. Okay. We haven't fully made up our mind on what it's even actually going to look like in the end. And by the way, all of this is in hardware that's not available yet. And so that's why I'm normalizing the values too. So we get a better picture once we actually have a conclusion on can we use PELT. But we might get to a point where we say, okay, it looks like we aren't able to do that, so we might give up, or we'll say, oh, we actually can get to par with WALT. So that's not clear yet. I'll give you more details.
Okay. Yeah.
Cool. Okay. I will move on if I don't have any more questions. Right, so adding value add set 2. If you look at answer 2, PELT becomes on par with WALT. There's some increase in memory, but again, it's kind of within run-to-run variation, so it's not really clear how much value add 1 versus 2 matters there. Moving on to PC mark, you see substantial improvement for web subtest. That comes to about, I think, close to 24% improvement, I think. And then some subtests like video, they're regressing a little bit, not too bad. It's still on par with WALT. If you look at writing, even with the improvement, it's still not meeting WALT. And photo, it's regressing, but it's still better than WALT. So it's kind of, general trend is towards improvement, but some cases you haven't caught up with WALT. But if you go look at power, though, sadly, the power increase is also pretty high. So that's a regression compared to PELT with value add set 1. But the power is now almost on par with WALT. I think that's about 101%. It looks like a huge delta there. So it's overall pretty close to WALT. And then if you look at performance per milliwatt, it actually is pretty much in line with WALT. So you're spending more power than WALT, you're getting more performance than WALT on more subtests. and you end up being on par with WALT in terms of efficiency. Whether we actually want to go that fast is not something we know yet, because like I said, it might be a performance that we don't need. And then if you go real world use cases, this is where things get a little worse. So with value add set 2, power increase for YouTube is pretty high. Power increase for light game 2 is also there, and then browser has also significant power increase. But at least browser, you can justify it with 24% increase in performance. That's about, I think, yeah, that looks probably close to like 20% improvement in power, increase in power too. But overall, at least we still feel it's worse than WALT, because that much regression in power for YouTube just doesn't seem acceptable. For browser, if you can improve it to be at least on par with WALT, that'll be good. So that's the current status for the real world use case. So if you talk about WALT versus PELT comparison, if you ask us, is PELT ready for mobile devices yet? PELT 32 certainly isn't acceptable from our perspective, because all the previous slides I showed you was with PELT 16. If you made it PELT 32, performance is going to be a lot more worse. So it wouldn't even come anywhere close to WALT. PELT 16 looks good, but it doesn't seem to be ready for commercial use yet, because some use cases are regressing in power. We need to kind of figure it out. And while doing all this work, we definitely saw some clear gaps in Upstream in terms of if a PELT can be usable for Android. The first one is, obvious one, is don't jump to max frequency for every RT thread. Maybe we can make it as a policy in Upstream. Somebody's asking a question.
Hello? So yeah, for this jump to max, the use of the, what we call it, uclump, a way to clump the max frequency for some tasks can be used as a way to minimize the max frequency for the RT task.
But that would mean you'll have to like hand tune everything, right? And what if your clamping isn't accurate? How are you going to clamp it across different chipsets, for example? It's a lot of manual clamping you have to do.
Yeah, it's a tuning, I agree with you.
Yeah, so I feel like it's a painful tuning, but it might be easier to just say don't do it and just let the PELT signals do the work, right? So if you disable a jump to max for RT, then I think the other things you would need is PELT tracking of RT threads at a thread level instead of run queue level, similar to how we're doing it for CFS threads. And then you can say enable utlist for RT threads too, and do migration fix-ups. Because migration fix-ups is also something that's clearly lacking. For jumping to max, I guess it wouldn't matter, but you can't jump to max. Power is just bad. And in terms of even like having util clamping, if you have, what if you have two different RT threads running back to back? I'm not sure how well util clamping is going to solve that. So I would think you might need to run faster if you have two threads running. But it's true we don't hit that situation often because you try to spread it. One more question.
For the RT task, I would say the policy or the main, what is assumed is that you need to run at, so for now it's at max frequency because you don't know how much time you need to do that. The goal of uclump is to say, okay, you're running at OPP instead of OPP max -2 will be enough to cover all the constraints, all the latency constraints of RT tasks, and that's only what we have. Otherwise, if you want to be more accurate, I would say, and that's also what the maintainer is providing, move to deadline task, where you can give some period, runtime, and deadline, and you will have everything.
Right. From a kernel perspective, if you want to run Android is what it is. So with that in mind, if Android is going to use RT and Upstream is saying jump to max at RT, it's not going to be a real world solution, right?
But
so
maybe Android is moved to
balance
deadline.
between those two. Can you pass the mic?
Yeah.
Thanks.
I thought like just avoiding to jump to max for RT. I think we have this in Android product, and it's just a one-liner or a couple of lines of code.
Yeah, that's what we do. We just comment it out. Correct.
Okay.
But the thing is, if we comment it out, it starts breaking in some other cases. That if a RT thread migrates, you might not migrate the load, and then also you don't have utilist, so you take a long time to ramp up, and RT thread starts waking up and running again.
Yeah.
So we can disable it, but it opens up a bunch of other gaps.
But Vincent, like the per thread RT stuff for PELT, I think it's a little bit more invasive than.
So the pair task, the pair RT thread tracking, that will be something difficult to get merged in mainline,
Yeah.
just because right now for the maintainer,
Yeah.
and in some, I understand his position is that there is no need because you don't have any, you don't know what is needed. And clearly I think that what you want is just to move on deadline. Such kind of task where you don't really need max performance and you need to balance that.
Okay. Yeah. If Android can move to deadline and make it workable, I guess I'm open to it.
I think doing that out of tree is still an improvement though, because currently WALT is out of tree and it does RT tracking anyway, and it's yeah. So you know we could potentially use the RT PELT tracking signal in the Android common.
Yeah. I'm just talking in terms of upstream, but yeah, if you can get them ported on
still
Android,
a step forward.
maybe. Yeah. What upstream here is, I guess, slightly vague. Android or actual upstream?
No, well, so the RT PELT tracking, that's going to be upstream, right? The
Right,
RT
right.
WALT tracking is not upstream at all.
No,
So
RT
it's
PELT
still
is
a
two
step
ports,
forward.
right? There's a RT run queue tracking and RT thread tracking.
Yeah.
Run queue tracking is upstream. Thread tracking looks like it's going to be hard sell, right? So yeah, if we can either get thread tracking into Android, maybe we can put changes on top and say if we can replace both. Sorry, WALT.
Changing in the meantime to use, or maybe it's quicker than when Android changed to deadline use in the meantime. Then we don't have to drive this on mainline.
But I guess, by the way, for deadline too, I don't think the DVF is fully sorted out. So it's not like that's a solved problem and it's like a magic bullet yet. I personally think it's not there yet for deadline too.
Maybe there are some use cases where it's still true that it's helped a lot because you are able to.
Yeah, maybe if I get the mic.
With deadline, you are able to know exactly what you need to run, how many, in how much.
It tells you how soon you need to finish, right?
Yeah.
But to figure out how to get there, like what frequency to provide, I don't think that part is done yet. The last time I looked at it,
Yeah, it's
okay,
merged.
but it's not.
No, everything is there. The point for us is right now is what we have is that because this deadline tracking, it's based on the period and running time. That's a fixed value, and when we want to evaluate the system utilization and how many compute capacity remain for other class, this value is not doesn't behave like the PELT. So sometimes we have some mismatch. That's
Yeah.
why we need a PELT signal.
Yeah, but then again, one other issue with the deadline. I mean, we can go into a little bit of a discussion that I think I have time.
Yeah.
So deadline has other issues, right? Some of the times when they're running a thread, they don't know exactly when it's going to finish, but deadline has a hard deadline, and after that, it completely throttles you.
No,
right?
there are some development to reclaim. There is this reclaim patch set where you are reclaiming more running time that you initially asked for, and if this remaining time is available, you can get. So you can.
Okay, yeah.
You can have more.
Personally, I'm all for it if we can get it working.
Yeah.
There's no tying to RT or not. It's more like an Android decision, user space decision.
You wanted to say?
Well, I was just going to say that, so this is, deadline for the display pipeline is a topic we're seriously evaluating right now. So I would say it's not quite there yet. There are some issues, probably some things we need added to deadline. But hopefully we can get there. Now, I also had a question here, though. You say that PELT 16 looks good, but not ready for commercial use. And based on the graphs, it looks like that evaluation is based purely on YouTube power. Is that kind of where we stand?
No, not.
Because the rest of it doesn't look like you would come to that conclusion.
Well, browser and those game is also worse. YouTube is also significantly worse, right? But again, it's all over the place in my opinion. It's not clear that I can say, oh, it's a good thing to go. Let's flip onto it, right? So we need to be more confident saying, okay, we can switch to PELT and they're not going to cause regressions. And at least based from this data, I don't think I have that confidence yet, right? And this is also only 5 different use cases we've tested. So obviously a lot more to test.
Yeah.
So with the limited data set, that's the current opinion. So yeah, we can debate about things that are missing, either in RT or in deadline. But we are clearly lacking certain things compared to what WALT does today for Qualcomm. And is WALT actually worth maintaining? So WALT comes to about 8,000 lines of code on top of the baseline kernel. And with value adds at 1 and 2, it comes to about 1,200 lines of code, porting them on top of PELT. And even if you finish porting all the other value adds, I think worst case we expect is 4,000 lines. That's like 50% reduction in number of lines to maintain. So I think it's a better maintenance, it's a good reduction in maintenance cost. So if you can actually get to the reduction in maintenance cost and be in par with WALT, that would be a win-win. Or if you're better than WALT, that's even great, right? So that's what we need to hope for. Can PELT actually get there? We definitely plan to try. It needs a lot more testing and a lot more real-world use cases. 5 of them isn't enough, obviously. We're hoping to get there by porting over the rest of the value adds and continuing to debug the values we have right now. So even though the power is like this, that doesn't mean it's done. We might have a bug in value add too. So this is like super early data. So we need to look at the traces more closely to see what's going on. And I think we actually have some more changes that will make it better, but it's too late to present it here. So I'm just kind of presenting what I have. And then we also have to do some more tuning of the system tunables. The way a load is represented by PELT versus WALT is slightly different. They're not significantly different. Sometimes PELT gives like 10% higher utilization signal. Sometimes WALT gives a higher utilization signal for the same load in terms of, say, 1024, the capacity. So we might need to nudge some of the other tunables to kind of get back some of the power impact. So those are the 2 things we plan to try to see if we can get PELT to where WALT is in terms of commercial use. And that's about it. Any questions?
I have understood that you can't really describe what are these value added, but is it linked to the load tracking mechanism, or you use that in the scheduler? I mean, all this added value, it's not really about
not for fully understand, but I can say that it's not changing how PELT signal itself is working.
Yeah,
right? We're not changing geometric series, for example.
It's how you use that, in fact.
Exactly.
Okay.
Yeah.
Good.
So we from ARM, we also had done a lot of PELT WALT comparison over the last 2 or 3 years or so. And there was always one test case, which is write test case in PC Mark, or even the web test case.
I think you mentioned right.
Yeah, so we saw that PELT is worse in those test cases all the time against WALT, and it would be nice if you guys could really understand the task landscape in those tests and maybe feedback to the community to say why WALT is better there.
I haven't actually known
because
why.
Yeah, there might be room for improving PELT specifically for this specific test case, and so far we were never able to go deep and really figure out why for this specific test case PELT is worse.
Just, I think that you have used a big.LITTLE platform to do all your tests, isn't it?
Correct. Yeah.
Okay.
Big.LITTLE.
Yeah, that give another
The domain of
another
complexity.
domain of change, yeah, compared to if you use SMP.
Yeah. Right.
That will be different because even for the EES, I'm not sure between what is about to be merged and what is in the 100 command kernel. There are some differences as well. So.
Yeah.
Maybe that would be interesting to use an SMP system.
Oh, okay.
Just to make a
comparison, you mean?
Yes, just to
Okay.
make the comparison. That's
Yeah.
that's easy to say, more than to do, but
Yeah.
just to see how
Yeah,
this big.LITTLE
exactly.
stuff enter in the picture.
Yeah. Oh, I'm sure it enters a lot.
Yeah.
Yeah. Any other questions? Cool.
So what sort of timeline do you see for this, the remaining work, the porting of the other value adds, tuning?
That's a hard question. So we spent about, I think 3-4 months on this. Forgot exactly to port these 2 value adds. So I'm guessing probably at least till end of the year, probably maybe more.
Okay, so I'm assuming I probably already know the answer to this question, but there's not been, you guys haven't done any sort of days of use testing?
So the looking at real world use cases is to get an idea of days of use, right? what is days of use is not well defined, at least publicly, right? There's no common public definition of days of use. So we're just looking at common use cases, a few games, and then using that to get an idea. But internally, eventually the goal is to do Qualcomm's internal full days of use testing to figure out if it's good enough. Cool. Going once, twice, thrice. Cool. Thank you.